Normally, as a mechanical engineer, you're not really in the code. We decided to do this programming language and learn it from the ground up, and we didn't think that we could do it. Like I said, 2 months, we turned around and did this entire project.
Hey, my name is Kiko.
I'm Matt.
I'm DJ.
I'm Ted, and we're Team LabVIEW from Georgia Tech.
LabVIEW is basically a smart starting block.
In simple terms, it makes runners faster. It helps them with their start so they can get their technique down and get to the finish line faster.
Ready, set, go!
So we met with a track coach at Georgia Tech, and he was really instrumental in helping us define the metrics that we ultimately ended up providing.
Currently, there's some systems that allow coaches to measure reaction time, but they're very expensive. And in terms of video and tracking the runner's movement, there's almost nothing at all. The system that we built is able to combine both of those into a single package that's much less expensive and offers a lot more functionality than they currently have. This is the custom footpad that we built for our project. It's an aluminum footpad that we milled out. It has strain gauges and an accelerometer underneath, and it feeds into the compact deck over here.
So we've got this HD webcam set up here to capture the first 3 steps of the runner's trial, and we've got LabVIEW, Vision Builder, and Vision Assistant set up on this computer to acquire the images and process it in order to give feedback to the coach and the runner.
Really, when the video analysis started coming together and we were able to get tracking on the feed as they ran through the frames, it was so awesome to see that and see that actually my work had paid off.
At first, it was difficult for me to sort of wrap my head around the idea of a graphical programming language, but once I got it, I got to see how powerful LabVIEW really was.
The really unique thing about LabVIEW is it's a programming language, so it can do all the other things that any other programming language can do, but it's a graphical programming language. So really, it's so easy to just put in blocks, connect those to other blocks, and do whatever you need to do.
It really helped us sort of focus on the problem, focus on what we needed to get done, and not on the minutia of syntax and little things here and there in the code.
One thing that was really neat using National Instruments hardware and software is the ability to plug and play. We used a CDAC with 2 spots. We had 2 modules we put into the CDAC, and that went straight into the computer. So yeah, I think it's probably the easiest thing I've ever used with a computer. Literally, I'm being serious. You plug everything in. You can't even put things in the wrong way. There's really no time you need to spend troubleshooting, getting data to the computer, because you can kind of just hook it up and it works.
I'd had experience before with MATLAB and even some object-oriented languages like C++ and Java, and especially when it comes to working with things like vision. I don't know how I would even begin to do things like track markers or calculate distances between different pixels in an image using those pieces of software. So.
Engineering is all about solving problems, and National Instruments hardware and software allowed us to do just that.